Okay, so today we'll be seeing about the circular queue. So these all I have already told you. There is a special behavior even if there are any unused space in the beginning. When the queue has reached, that is your rear part will be in 5, R will be in the 5th position. That is in 6. That is your total capacity is 6, but R will be showing it as in the 5th position. That is maximum size -1 or n -1. Can take it in any way as you specify the maximum limit capacity. So when R is in the last position, even though you have dequeued it previously and you have cleared this 1 0 1 2 spaces free now, but still you have some sort of issues where false issue. That is a false. Actually, it is the space is there, but that particular issue will be taken as the in linear queue alone. That issue will be called as false overflow issue because your rear will be in the 50. It does not keep on checking each and every element here. What it will do is it will finally, first condition when you are going to insert any element, it will go and check the rear only. R is equal to whether R is equal to n -1 or maximum size -1. If it is true, then it will tell that your queue is in overflow condition. It does not bother about the other conditions at all. So what it will do, it will tell that it is in overflow condition and we cannot insert even if there are some unused spaces at the particular array. That is the drawback in the linear queue. But in case of circular queue, you know that everything comes in a rotation. So that's what we were seeing it in the last class also. Just I'll go through one or two slides already we have seen. So here normally when you insert, your normal queue procedure is your head will be, after each DQ, your head will be incremented. That is your front will be incremented. After each NQ, whenever you're going to NQ, your tail will be incremented by 1. That is your adding. Okay. And whenever you're DQing, front portion will be deleted. So head will be incremented. So first when 0 is deleted, head will move to 1. When 1 is deleted, head will move to 2. Likewise, your pointers keeps on moving. So same thing only as I told you in false overflow issue. See here, your entire queue is full now. Your entire queue is full and you have made some 4 DQ also. So you know that here there are some unused spaces. But now when you try to call the NQ again, what will happen is it will check that your rear is here now. R is in the 49th position. So it will tell that it is full. But there are some spaces left out here. So unused, that will be wasted also. So that is the drawback in your linear queue. So the solution of your linear queue, the drawbacks in linear queue is overcome by the circular queue. Circular queue, head and tail will be keeping on moving around. Even see head and tail, then when you insert again, there is a numeric where you have to find out this position. So it will find out it is circular, right? Since it is circular, next to 49, 0 will come. So what it will tell that 0th position is free. So in that case, you have the possibility of inserting it in the 0th position. This will be a little bit similar to your circular linked list. In normal linked list, your head will be always the first element. And your last will be the end of null element, where the null address is there will be the last element. But in your circular linked list, your last will be pointing out to the first one. So the advantage there is anywhere else in the middle you can start it as a head because finally the last one which is traversed only will be taken as the last part or the tail part. So in circular always there will be a rotation basis where it can take the next part. So here the same thing, circular queue is a linear data structure but which the first position is connected with the last position. Similar as your circular linked list. So where the positions will be 0 and max -1 will be adjacent here. But in normal queue, your 0 will be here in this end. But in your last max, your rear part will be in this end. And your front part will be in this end. But when your circular queue alone, your rear will be here. Your front is here means your rear will be here. Rear front will be nearby. 0 and -1 will be adjacent. As you keep on, so it is also called as ring buffer. So normally Q procedure is first in, first out only. So operations involved NQ and DQ. So the variables used, these are known things. Maximum number of entries. Front is the element where you NQ, that is where you DQ it. Get the front item also you can get, and DQ also happens in front. Rear is getting the last element, and NQ happens in the last. So similar concept as your linear array. So now your concepts of circular array is, see here, front, this is 0 is taken as the front position. So when I want to insert, it will tell it as rear plus 1. There is your front and rear, first initially will be same. Now when I am going to insert the next one, R will come to 1. Then again I am inserting 30, R will come to 2. R will come to 40, R will come to 50. So now my rear part is in here. Now if I want to insert, my R will increase to 4 plus 1. Okay, and my next rear will increase to here. Next rear will increase to here. So so now when I'm inserting all over here, this will be front, this will be rear. So when I'm inserting something around 40, 50, 60, so this will be rear and this will be front part here. So your checking condition will be, this is your maximum size. So there is a numerics for checking the overflow condition for this circular array. I'll tell. So this is the diagrammatic representation. So first your front and stepwise, front and rear are here. Then your rear part is increasing here, then here, then here. Then again it comes to here. These all are all are NQ only. This is also NQ. Till here it is NQ only. Now it is DQ. When it is DQ, you know that your front portion 14 will be deleted. When a DQ is called, 14 is deleted and your front moves to 22. Next, again DQ is called. So your front moves to 13. Again a NQ is called. So what will be the NQ? Solve. And this space will be left out as such. Because since it's a circular queue, this left out spaces will be actually used by the next insertion number.
That's what I said.
Okay, ma. Conditions used in the circular queue will be, the front must point to the first element. The queue will be empty if front and rear are same. And when a new element is added, you know that you have to increase the rear plus 1. And when an element is deleted, you have to increase the front plus 1. So same as your linear queue only. So here how you are checking the full queue is, rear is equal to size minus 1 and front will be 0. Normally if your front is 0, your front, see if you are in your circular queue, your front is 0 and rear is equal to size minus 1. That is this part. Here your front is 0 and this will be 1, this will be 2, this will be 3 and this will be 4. So actually my size is 5. Rear is size minus 1, 4 and front is also 0. So that means there are no unused spaces. If your front is in the first position, we can assume rear is maximum minus 1 and your front is in the 1, then this space is free. It is assumed that, or it is noted that this space is free. But when your front is 0 and your rear is your front minus 1, that means your circular queue is full. That is the meaning. Okay. In your normal queue, you will not be checking this front is equal to 0 because we don't mind that at all. You will be checking only rear is equal to size minus 1. If your rear is size minus 1, you will assume that your queue is full. But in your circular queue alone, you will be knowing that if your rear is equal to size minus 1 and your front is 0, that means both are adjacent, both are near. When it is near, the meaning is your queue is full. But if you are, and another one also, you can either do like, or else you can see, yeah.
Ma'am, one doubt. According to the first part of this, I have one doubt. Could you go up to the diagram once?
Yes.
Here, if you see the first diagram, then the place where there is 14, that will be 0, right?
Yes, this is 0. This
So then
will be
accordingly,
1, 2, wait, 3, 4. Okay.
so here at the, so we'll follow this numbering only, right? We'll,
Yes, yes,
because
yes.
in
This number only.
QDQ, so the numbers in the last diagram will be different.
Last diagram is different.
Yeah, so then the front will not be 0, right? Front will be 2 and the rear will be 1. So the first condition is not satisfying there, which you just
So
showed just
in
now.
that case, if we are here, you are having empty spaces. I took this diagram because the queue was full. But when you initially follow, it will be this, or this particular procedure only will be taken, ma. If your front and rear are same, front and rear are same means your queue is not full. It is like you have some elements. If your front and rear are same means that is only one element is there. If your front and rear are is equal to -1, that means no elements are there, because initially front and rear will be -1. That means your queue is underflow. When your front and rear are same, wait, when your front and rear are same, it is you're having still more elements can be increased. But when you keep on moving like this condition, why I took this diagram for showing you that your queue is full, your particular last diagram satisfies this condition. That is what I took this diagram and showed you and marked you. But whatever which your
Ma'am, but the numbering does not change, right? The numbering will
numbering
remain
will not change.
constant.
Numbering will not change. It will be constant only.
So in the last diagram, the front will be 2 position, right? It won't be
This
0
is
position.
circular, no, ma. Circular, no. So your rear and front will be keeping on moving. Rear, see here, 20 is inserted. Then your rear will be again 3
Ma'am, the
only.
rear
No,
and front
next
will
time.
move. That I understand. But
Yes, okay.
the position of the number, like the blank 0, 1, 2, 3, 4, that positions won't move.
That
Right?
will
You're
not
just shifting
change.
the front or rear. You're not shifting
That
the
won't
position.
change. That won't change. That won't change. But
So
here
the
I have not numbered it, no. That's what I told you here.
Okay, so that is why I'm saying the front will be 2 and the rear will be 1. And in the condition below, it was given front is 0. That is why I'm asking. Here, though, it will be 2, no, regarding the first diagram.
See, wait. Wait a minute. I think you are confusing. The thing is, listen here. When a circle is there, like this, wait, I will draw and show you here. Okay. So your front, maybe this I'm assuming as 0. This I'm assuming as 1. This I'm assuming as 2. This I'm assuming as 3. Okay. So now I'm inserting an element to the first position. A I'm inserting here. Okay. So my front and rear are same initially. Okay. Now the condition will check it now. Rear is equal to size -1 and front is 0. Right. But rear is not size -1. Right. Is rear size -1? Your size is 1, 2, 3, 4 is your size. Okay. So size rear is not. So this condition is not satisfied. So that means it is not an overflow condition. Next, I am going to insert B. So what I will do, my rear part only will increase. So R plus 1. So this will be cancelled and now R will be here. So I am inserting B here. Again, my R is in this position. Again, it is checking. Front is 0 only. But R is equal to size -1. No. Right?
No, ma'am.
It is 1 only. So again, I am inserting C now. R plus 1. So now my R will come over here. Now again it will check if R is equal to size -1 and front is 0. Okay, that part is okay. But both should be satisfied. This is not true again. So again I am inserting D over here. Okay. So my R will move over here. Okay, now you check. R is equal to size -1. Is it true?
Yes, ma'am.
Yes. And front is 0?
Yes, ma'am.
Yes.
Ma'am,
And
so,
also...
ma'am, one more thing. Just here delete A and then insert E. So the front will become B.
So what I will do is, I'm going to call the DQ part now. So what happens? This will be removed. That is the meaning, right?
Yes, ma'am.
So this will be removed. And what will happen is, this front will be moving to this part. Okay. Okay. Now check. Now
And-
check. Now I am calling the insertion now. Okay. Now I am
Yes, ma'am.
calling the insertion. So again it will check. VR is equal to size minus 1 is true.
Yes, ma'am.
Because it is true. But my front is not 0, right?
Yes, ma'am.
So it is not in a overflow condition. I can insert now. So
Yes.
when I'm inserting, default my D again will come over here.
Yes, ma'am.
When
And now,
rear
ma'am,
will
if you
come now
insert,
here.
ma'am.
So that means again E is wait E is inserted here. So my rear is now R, right?
Yes, ma'am.
So rear is this will be decrease this now. Okay. So now this will be, listen here, this is now in the 0th position. Right? 0th only, no? Yeah,
Yes,
0
ma'am.
and this is 1. Now you see R is equal to size minus 1.
No,
No.
ma'am.
Front is also no. And you see here. This also each time you have to check. And both the condition. Rear is equal to front minus 1. Is it true?
Yes, ma'am.
Then Q is overflow only.
Okay, ma'am.
Okay. So this is R condition, right? R. This is not and, this is R condition. So either this or this, if it is satisfied, your Q is in overflow condition. So initially when it was not changing, that is when it was accurately when F was 0 and R was 3, this condition was satisfied. But suddenly when I'm dequeuing it, my front end has changed to F, that is 1. And my R was again, after insertion, my R became 0. At that time, this condition will fail, but this will be satisfied. So your Q is full only. Clear now? Okay. So this is how we are checking for circular Q. But normal Q, this condition is not at all needed. Only you will be checking maximum size minus 1. And for dequeuing, whether the queue is empty or not. If your front is equal to minus 1 or your rear is minus 1 also, your queue is empty only because no more elements are in the particular queue. So difference between, I think you know it. In the normal queue, we can insert elements until your queue becomes full. But when it is full, we cannot even insert if there is any space left. But in your circular queue, you can use the unused memory space. So these are already told. And this is the numerics. Numerics for circular queue. When you want to increase the head, that is your rear part. This is also called as rear. Head only we are telling it as rear part also. And head is front. Sorry. Head is front. So this is called as F and this is called as R. Okay. So when what capacity head is there is, what index the head is there, it keeps on increasing plus 1 mod capacity. Because circular queue, there is a specified capacity, right? So you will be, since it is circular, you cannot keep on just incrementing it one by one. Instead, you have to check with the mod value also. So I'll show you an example for this. So these all already discussed in the previous slide, but as a paragraph I have mentioned it here. Front element deleted, it occupies space. So here you can keep on moving and find out, use the unused spaces also. So for this numerics, I will show you one example. So before that, okay, I'll show you the example and then come over here. Now see here, consider the circular cube with n is equal to 5. So either you can start from 0 or 1. So in this diagram, it is given from 1. Does not matter. So when it is starting from 1, you initialize the rear and front as 0. When it is starting from index, if normally you start from 0. So you give it the rear and front as minus 1. Okay. Now listen very carefully. Now insert 10. Okay. You are going to insert 10. So your rear is 0. Front is also 0. So when you are inserting 10, what will happen is 0, that is your rear part is 0. So you have to increase or you have to increment the rear part. So 0 plus 1, that is your previous thing, 0 plus 1 mod, what is the capacity here? 5, right? N is 5, mod 5. Okay. So 1 mod 5 is 1. So your rear has been increased to 1. And similarly, your first, when you have inserted the first element, your front also will get incremented. So now the next one, insert front, otherwise let it be like that. Front rear is getting incremented. Now see here, front, then you have to initialize to the first position where you have increased the rear part. Now insert 50. Your rear is 1 now. So 1 plus 1 mod 5. That is the meaning, mod 5. So 1 plus 1 mod 5 will be 2. So again it is 50 is inserted in the second position. Now insert 20. So 3 mod 3 plus, it was 2 first initially, right? Okay. So 2 plus 1 mod 5, so 3. So rear is 3, front is 1. Now see insert 70. So same thing. So your previous rear was 3. So 3 plus 1 mod 5. So it has become 4. 3 plus 1 is 4 mod 5. So in this case it will be 4 mod, not you have to keep it as mod 5. Similarly here it is 4. So I think this happens over here for this part. So 4, it will come here 4 mod 5. Then again this value will be taken. So 4 plus 1 mod 5. So here 5. 4 plus 1, 5 mod 5. Right? 5 mod 5 only, no? It will come. Here there is
the last operation is delete, not insert.
Yeah, here it is front. Yeah, that's what I was having. Okay, so good. Okay, delete front. So front means here it will be. So what part will be taken is it will go to 1. Now, till now we have increased the rear part. That is we are inserting. So 0 plus 1 mod 5, then 1 plus 1 mod 5, 2 plus 1 mod 5, 3 plus 1 mod 5, everything. So when sixth operation is delete operation. When delete operation is called, it will go and check the front part only. So front is initially 1, right? So what will happen is 1 plus 1 mod 5. That is 1 plus 1. Because whenever you have to keep it in mind, when you are that is when you are inserting rear plus 1 mod 5, when you are deleting front plus 1 mod 5. So front plus 1 mod 5 means your front is your 1. So 1 plus 1 mod 5. Okay, so 1 plus 1 mod 5 is 2. That your front will move to the second position now. So this is how similarly.
How did front become 1? It was 0 in the starting, right?
No. Here in this diagram, it is 1 only given now. That's what I proceeded with the same.
Rear equal to 0, front equal to 0. Then we added one element, so rear became 1.
1.
But front still be 0.
No. That the thing is, listen here. When you have inserted the element, you have to increase first. For the first insertion alone, your front will be assumed as the first part. You have to write it in code. Your front will become the first element always. After that, you should not increment the front at all. Okay. Your rear will be incremented first. Then after that, you have to assign the rear to front also. Because the first element will be always holding that particular value. After that, you won't disturb the front. You will be keeping on increasing only the rear part. Okay, because when a queue is being assigned, and only until the first insertion and deletion, first insertion, your front and rear will be 0 or minus 1. When the first element is being inserted, where the first element will hold both the values of the front and the rear. After that, each time when you insert 1 by 1, your rear only will increment, your front will not increment at all. Unless deletion operation is being called. Okay. So here, then only you can move the front to the next. Otherwise, if it is in 0, you cannot move it actually. Okay. So front, this will be incremented to this. So this operation you can take either 0 or minus 1. Based upon what you assign, based on that you have to start to assign this also. Index value also. So now see here, insert 100. So which one will be increased now when I insert 100? Which one will be increased when I insert 100? Hope anyone can answer.
Rear will be increased now.
Yeah, rear will be increasing. So rear was 4 first. So 4 plus 1, it will become 5 now. Now again insert 40. Rear was 5. So again 5 plus, that is, you have to use that mod also. So what will happen is, see here, that's what we are using unused space here. In this one we have deleted first. So one is free now actually. So what will happen is, when your rear is 100, insertion, when you are asking to insert 40, the previous rear, that is 5, your value was 5, right? So 5 plus 1, 5 plus 1 mod 5 plus 1 mod, what is the capacity? 1, 2, 3, 4, 5.
5.
Okay. So 6 mod 5 is, remainder is 1, right?
1.
So it will come to the first position. Since it is circular queue, that's what we are using this line, mod. Otherwise, as a normal queue, you can keep on inserting +1 and go. But to find out the next value after once, if the queue, it has to come in circle. Now it will be seeing that 5 is the last position actually, but there are one unused space. So the initial position was 5, 5 plus 1 mod 5. So 6 mod 5, your remainder will be 1. So in your rear is now taking the value of 1. Now again, if I insert 140, you can see here already your rear is 1 now, and it will check always. I told you, whatever value you are going to insert, first it will check whether if rear is equal to max minus 1 or n minus 1 and front is equal to 0, or rear is equal to front minus 1. So in this case, you could see that rear is equal to max minus, your front is 2 and rear is equal to max minus 1 is not, in this case it is not true. The other condition, this condition it will hold. Your front is equal to rear minus, that is, your rear is equal to front minus 1. So in that case, this condition will be checked. Your numerics, this condition will be now taken out. This condition, rear is equal to front minus 1, because front is equal to, you can see here. So either in that both condition, any one condition, you have, if it satisfies even, your queue is overflow, it cannot insert. So once if you want to insert, then again you can call the delete. So which one will be deleted? Now your front is 2. So when I delete 50, my front will become 20. That is, your third position will become front now. So otherwise that numerics you have to follow. By visualizing, I'm telling, it will come here. But actually the numerics only will be followed. So my 2 plus 1. 2 plus 1 mod 5. 2 plus 1 is 3. 3 mod 5. So my current front will become 3 now. Then again I'm calling delete front only. My previous front is 3. So 3 plus 1 mod 5. Right? So 4 mod 5, my front will become 4. So again I'm calling front. So again this previous front value is 4. So 4 plus 1 mod 5. So your front will become 5. So likewise, so there are many unused spaces. If you want to increase, if you want to insert, you can insert. Likewise it goes. So now if you take the this condition,
Ma'am,
yes.
ma'am, how do rear and front become 5? Because 5 mod 5 will give 0.
Where, ma?
I'm in the 7th and 12th step. You're
Yeah.
getting front equal to 5, but 4 plus 1 is 5 and mod 5, that would be 0.
Which one you are telling? Here it won't come to 0 total. What are you telling? Delete front, ma. Delete front is 4. So 4 plus 1.
Yes,
Delete
ma'am,
only.
5.
So this is.
Ma'am, he's saying that here we did 3,
No.
in step 11, we did 3 plus 1 mod 5, we got 4 as the remainder. In the next step, when we'll do 4
Yes.
plus 1 mod 5, we'll get 0 remainder. So it's coming but 5 position, that he's saying.
Oh, okay. Okay, actually, start from 0th position. It will come, not 0. 0th position, it will come correctly.
Yes.
You have to always start from 0th position and initialize the front and rear as -1. Okay, that is the correct way to follow actually. So since we got this diagram, I have put it over here, but have a the practice of front and rear should be -1 only, and your index will start from 0 to any value. Okay, so that at that time when you apply the numerics, it will come correctly, and your formula also will work only for that correctly. Your this maximum size formula will work for that only.
Yes, ma'am.
Sometimes these conditions. Okay, so have the practice of that. Now, so here I have used that insert and delete operation. So if front is equal to rear plus 1 max, you can tell, and you can include that other lines also, whatever condition checking which I have told you before. So that also you can include it if you want. So the overflow condition, you can use either that numerics or this one. And other things else, if there is not overflow, your front is always -1, and your front and rear initially when you increment, it will become 0. Else when the already if element are there, then this is what the initial condition which you asked before. So when that is the first element to be inserted, both the condition, your front and rear should become 0. If your front is not -1, that means your front is 0. In that case, you have to increment the rear part. Understood? Someone asked me about how the front moves to 0. So if whenever you are inserting, this condition will be checked. If front is equal to -1, you will be telling front and rear are 0. Both will become 0. That is the first element. It will point out to the first element. In case, if there is a first element there available, then our procedure is only to increase the rear part. Okay, and now insert the particular element. And for all, even this is for array, you are writing this line, but for linked list, I think you know to the position you will be inserting to the rear of next will be your new node. And these conditions will be exactly same in your linked list also. I think Sanskriti on some other day she was asking about how that condition. See, only the particular line which changes for array and your linked list is this line only, the insertion line. Other conditions will be same only. So to check the overflow condition, underflow condition, or max, whatever it is, your conditions will be exactly the same, and your numerics also are going to follow the same. Only the pointing method or your assigning method or the value which you insertion method only will be different. Here you will be using the array concept. There you will be using rear of next. Using the pointer, you will be using rear of next is equal to new node, and new node of next is whatever method, whether it is null or the next element or whatever, based upon the current situation, you will be pointing it out. So for delete operation also, when its front is -1, there is nothing to be deleted. So Q underflow, else you delete it, and if front and rear is both are same, means that means it is -1, else you increment, that is the only element, then it becomes -1. Otherwise you increment the front position. Okay, so this is what your circular queue. And applications of queue, I have already told you so many applications when I started the queue, mainly in when you are asking for a resource or in a theater or mall or anywhere, wherever you go, you follow a queuing system. And in computer system, when the server is when a client is requesting the server also, it will be accessing only by queue basis. And even call center, queue only will be followed. The first one who is dialing will get the connection first. Until then, others has to wait after that. So this normally wherever we follow the queue procedures. And pros and cons is it is easy to implement, limited capacity with fixed array. This is for linear. But when you go for the circular queue, you can go with that particular behavior can be overcome by circular queue.